So I spotted this thing on eBay recently. There's actually quite a few of these on eBay UK at the moment. It's advertised as a gyroscope amplifier module, so obviously I didn't really have a clue what it was, other than it was some sort of gyroscope, and the fact that it was had this sort of shock bouncing suggested there was actually a gyro in it. It wasn't just a bunch of sort of fairly boring electronics. So thought it'd be interesting to take a look at it. This top box has got its own connector to the front, so it's obviously another bunch of electronics that probably connects to both of these connectors here. And you just unscrew that connector and this whole thing comes separately, so that's probably for maintenance. They can swap these two units separately. Right, got some rather nice looking electromechanics in here. A couple of, and look at that, you just touch it and it just carries on going. Super high quality bearings there. And it looks like there's three main units. There's these sort of two interlinked, some mechanical parts, and then there's some electronics over here. This unit just unplugs. So there's just a bunch of electronics, a few transistors, some heat sinks, little transformer, nice expensive little connector there. So just a few odd little random bits of electronics, nothing nothing very exciting. And now that's out, you can actually see this looks like the main gyro here. One thing, this is obviously quite compact, so yeah, this has come out of a fighter aircraft, so obviously you're trying to get everything as miniaturised as possible. A little detail here, we've got these nice little precision wiping contacts to transmit connections to the rotating part on there, and also on this other side. This part lifts out quite nicely. You can see we've got actual gyro bit that's only rotating, so we've got sort of one axis there and the other axis is the rotation of this. A few more wiping connections to the centre bit. We've got three connections there, another three here, and also around the outside we've got what looks like a sort of induction motor core. I think we saw something very similar on the other gyro. I think this outer part forms an induction motor, so that it can be manually positioned, so that when it's on the ground it can be manually sort of set to a known reference position. And on the outside that actually goes around what looks like an aluminium ring that acts against the ring with a sort of generating eddy currents within the ring, just to provide a small amount of force, rotational force. So I'm not sure why they did it that way, so I would have thought it would make more sense to put the aluminium here and then put the this on the outside, so you didn't have to sort of commutate the connections through here. Seems a bit of an odd way to do it. I'm sure they had their reasons. This rotates a little bit less than 180 degrees. Obviously this was free to rotate in all directions. A couple of little devices here as well. We can actually see that's the actual rotating, that sort of copper coloured. That's the actual rotating mass. Which again is a sort of super nice bearing that will just move a little bit and it just carries on for quite a long time. Right, these look like they're just little coils, but there's a sort of shaped piece, so it looks like these are designed to go very close to this rotating gyro part. I can only imagine that's some sort of eddy current drag type thing. I'm not really sure what that would do. I'm not sure whether that would be sensing or whether that's sort of put more position control. Yeah, if actually there isn't anything that there's this induction motor to move it this way, but there actually isn't anything, I don't think, that's moving it in this direction. So I wonder if this is either sensing or actually exerting force by, if you put some current into that coil, it'll produce some eddy current drag on this, which looks like it's either probably brass. Looks like that's mounted in a sort of sleeve, so I'm guessing that sleeve probably adjusts the position so this gets quite close to the rotating part. This bit in the middle, I think this is just an interconnect board. There's also this, which looks like some sort of adjustment. Which may just be a balance. Yeah, I think it may be either a balance weight or I can't think what else that would be. So we've got some wires going in here, which would presumably be the motor coils. A few more coming out of there. See, these have got some little plastic insulation washers because they screw directly into the metal. Right, so this is the actual gyro unit. It's pretty heavy. It's got at least a pound or so, I think. Obviously that's got a nice quality bearing on it. You can see some little drill marks here, which would be where it's been balanced by drilling little bits out of the metal. You can see the balls of that end bearing in there. Again, that's just the inner core of looks like an induction motor type core. There's 6 connections on there. Again, obviously all the weight's concentrated on the outside to give the most inertia for a given mass. Again, here you can see all the drillings for the balancing. So I'm a little bit curious as to how these coils here work. I mean, there must be, I think they must be doing some sort of sensing, because otherwise there's nothing to determine the the position in that axis. There's no other sensing. So wondering the fact that as that rotates, the influence of that coil, the influence of this rotating metal on this coil changes as its position changes. Maybe it's perhaps a coupling effect between these two coils, I'm not really sure. a bit fiddly to get off. There's actually a collar underneath this with an Allen screw that you need to get at from the side, but once you've done that, this lifts out. Now this sort of looks like the construction of a motor, but I suspect this is something like a synchro resolver, which is something I talked about on the Decker control panel thing that I took apart a while ago. I'll put a link to the video underneath, which is basically a method of transmitting a rotary value down a wire between two mechanical parts. This does seem quite big for that, but I can't really see what else it would be. So there was that ring around the bottom of the gyro half, which I'm sure is for positioning, so I think this is going to be basically a sensor. Interesting. Looks like it's two sort of independent bits. So we've got all the brush contacts on here. We've got two separate rotors that look like they're separated by, I don't know if that's an aluminium or a steel shield. That's magnetic, so that's probably magnetic shielding. Those two coils in there look pretty similar. These, well, that's got some sort of grey paint on it, and this one hasn't. And the windings on this are much finer than the windings on that one. But these ones look the same. Well, that's quite interesting mechanics. Sort of gyro plus some slightly mysterious sensing arrangement. Let's take a look at what's in this other box. Ooh, more mechanics. And this little connector goes to there's two adjustment pots inside there, and then there's this big multi-way connector, so you can unplug that bit and if necessary unscrew that connector to get this free. Let's do that. Of course, being sort of military stuff, we've got this beautifully hand-laced cable looms with all the marker numbers on them. Very typical for this sort of construction. Again, same here. Back of this connector. Right, this part here is clearly the power supply. That's a transformer. Obviously, because aircraft use 400 Hz, one reason for that is to reduce the size of things like transformers and generators. So that's probably taking perhaps something like a 115 volt 400 Hz signal and stepping that down for the DC. That, I'm guessing, is just probably a series choke for smoothing. and there's some interesting looking sort of capacitors in here, some old-fashioned stud diodes, a few other capacitors, some transistors, 2N1054 Fairchild. Certainly can't immediately see any dates on any of this. My guess would be late 60s, possibly very early 70s. Actually, yeah, there's a date on here that says 2-74, so perhaps February 1974 as a manufacturing date. Down here, this looks like just a big interconnect board, and guessing that's, I'm sure that could be a relay or a transformer or something. Just made by Ferranti. Might have to X-ray that to see what's in there. Might just be something like a little transformer or something. Right, the X-ray machine's not quite in working order at the moment, so to look inside this thing I just used the poor man's X-ray, and it is just a transformer. You can see the laminations there. But here's the interesting bit. Again, these are those synchro resolvers which we saw in that Decker unit. These all seem to be coupled together. As far as I can see, all these units run at the same speed, and this one is geared down significantly. So, I mean, my guess is this is basically producing multiple synchro resolver outputs. So, it's probably, I think probably it's taking the signal from the gyro and then outputting it over multiple things. So that, for example, all the different aircraft systems that want access to gyro information, so they'll be like the cockpit displays, autopilots, maybe weapons guidance as well. So it looks like they've got four of these resolvers, all the same. That which is described as a servo motor, so perhaps the that unit inside the thing perhaps drives this and then drives all these, and then this other device here, which I'm guessing is some sort of encoder. Interesting little detail on these gears, they're actually split, they've got two sections. This is to avoid backlash. They've got a sort of spring, so they sort of spring to sort of grip the other gear it meshes with to avoid backlash when it changes direction. Interesting, there didn't seem to be anything to stop backlash on the big gears that coupled the that big part of the main section, which was a little bit surprising. You can actually feel notable backlash, but all this this mechanism here, all the gears seem to have these anti-backlash gear wheels on them. It's also got lock nuts to prevent these nuts coming undone. These washers go down there, then they get bent up the side of the nut to prevent the nut coming loose. Here's the anti-backlash gearing. You see it springs back. There's going to be a spring of some sort inside here. Yep, so spring there that's providing that function. So this is this mysterious encoder type thing again, made by Ferranti. Serial number 353. Oh yeah, so it's a sort of wire wound pot type device. It's what's generally called a servo pot. So it's a sort of very precise, super low friction. So you can just see the wipe around there. running around this wire wound core. It's only got 180 degrees of rotation, so I'd imagine maybe the other side has got the other 180 degrees on it. So this one's got a winding all the way around. Maybe this is just providing two different outputs. And that is extremely fine wire. Yeah, looks like sort of 4 connection points, so maybe it's providing some sort of quadrature type output. There's just this other extra output, so a no doubt stupidly expensive pot, basically. Again, producing output for something. I know it's for ANTI, maybe it's for some early analog computer or some sort of bomb sight type device. But so this whole thing just seems to be basically about a gal taking the gyro output and distributing it to various systems, providing multiple outputs for various different things. Now, one interesting thing you do if you've got some nice ball bearings and a shaft, generally it's bigger than this, but I'll be interested to see how this one works because it's sort of very free flowing, is make a ball bearing motor. Now there's a little bit of controversy about how these things actually work, but basically all it is 2 ball bearings and a shaft, electrically insulated from each other from each side, and the shaft just needs a little bit of weight to act as a flywheel, and you basically apply a high current from the outer ring of one to the outer ring of the other, and you can do it the other way if you've got a tube across it, but basically the current flow across the 2 rings of the ball bearings produces a rotational force. Many years ago I wrote a web page on this, which I'll link to here, but it's one of those fun little completely useless things, but just a quite amusing little gadget. So I've just got this shaft here, ball bearing each side. I've put it in the vice with some insulating tape over the jaw, so these 2 sides are insulating. Most sort of ball bearings you need a good few amps to get going, but this one actually, this is the second set of bearings on it. It trashes the bearings almost immediately, so don't do this with anything you actually want to keep. But this one did actually originally start at about 2 amps, but just for fun I'm just going to crank this right up to about 5 amps and just see what happens. Generally what happens is they speed up, and then as the bearings expand and start to seize up, they then sort of slow down, grind to a halt, and if you're lucky produce sort of lots of smoke from the oil. But let's just see what this one does. So I'm just going to give it a very slow spin to start it, then I'm just going to connect the supply. So I'm just going to get them moving slightly, and basically they'll carry on moving in whichever direction you start them. So I'm just going to give it a little spin to start it. Good. Spin it the other way. And they will actually go pretty fast when they get going, but so they'll generally start to slow down a bit. Yeah, it's dying down. Get a little bit of smoke coming out of the bearings now. Sometimes when they cool down they'll restart, but sometimes the actual surface of the balls gets pitted, so they're just not very good bearings anymore. Use some freezer to cool them down a bit.